Okay, students, now I will talk about the acceleration, the constant acceleration, of how to apply the equations of motion. We will see them. There are 4 or 5 equations. We will apply them, and I think they will be easiest to be applied. Okay, I need to start these examples. I have many sheets now. I will start them by mathematics. What if I have a function f of x is equal to y, and I need to find the value of this f of x or y at x equals 7? The function is 3x minus 5x squared plus 2x cubed. It is easy. I just use 7 and put it in each x, which is equal f of 7 is equal to 3 by 7 minus 5 multiplied by squared 7 plus 2 multiplied by cubed 7. This is equal to minus this will be equal to 462. This is f of x, which is equal to y. This is mathematics. There is no units. I don't need any unit here. Okay, what about this? This is x of t. It is another function. The name of the function is x, and the dependent variable is x, and the independent variable is t. I can now name x as a position and t as a time. In this case, I can convert this equation or understand it in physics vision or something like that. Okay, I need x at t equal 2 seconds. I can put 2 in t. Okay, so I need x of 2 is equal to 3 plus 5 multiplied by 2 plus half multiplied by squared 2. In this case is equal 3, 10. This is 10. 3 plus 10 plus half multiplied by 4 is 2. This is equal to 15. It is x. It is position. Now I can put the value of the unit. This is x of 2. I can apply that for the velocity. I can use velocity as a function of time, and I can use any function that I need. Look at this, 120 over t plus 5 exponential minus 15t, and I need the time at t equal half. Just I need to put half in t. Also, I can compute the acceleration at t equal 15. Just I need to put 15 in t each time. This is sine, this is ln or ln, this is pi. Pi in this case is 3.4, something like that. I think it is easy to substitute the value of the time in each function. Now I will move to the next part. Now if I see here, there are no relations between my functions. This one is mathematics. This is I need to compute the position, there is no relation between this position and this velocity and this acceleration. Now I need to use acceleration and position and velocity for a body, for one body, and I need to find the position and the acceleration and the velocity at t equal 15 seconds. I can compute now directly the acceleration. If I need to compute the position, I need to find v of t and multiply it by t. I know t is 15. I need also here the acceleration. I don't know the acceleration. V, I don't know. I don't know here. This is typo. No, not a typo. I'm sorry. This is t multiplied by the acceleration. I am sorry. This is equal to t multiplied by the acceleration a of t plus 5. Okay, I will be here later about these things. Okay, I need now to compute the acceleration. The acceleration at t equal 15 is equal to 12 over 3 multiplied by 15. This will be equal to 0.267. What is the unit of the acceleration? It is meter per squared seconds. Okay, now I can compute the velocity. Velocity at t equal 15 seconds is equal to t, which is 15, and multiplied by the acceleration at t equal 15, and I compute that, which is 0.267 plus 5. All of this will be equal, the velocity at t equal 15 seconds is equal to 20.267. What is the units of the velocity? It is meter per second. Okay, now I can compute and find the position. It is equal to x at t equal to 15, 3 plus v at 15. This is v at 15. It is 20.267 multiplied by t. T is 15 also. It is the same time for all of them. Plus half a of t. T at 15 seconds. The acceleration at 15 seconds is this value, which is 0.267. I can find the position now. It will be 3 plus half multiplied by 0.67. Okay, go to, it will be I'll be sure, yes, 307.01.385. What is the units of x? It is meters. Now I will talk about these equation of motions. We have 1, 2, 3, 4, 5 equations. I will not go how can we derive them. There are two ways to derive these equations. One of them is using algebra and you will see how uh, we can derive them during watching the videos. And there is another way, which is using calculus and integration and derivation. I will not go through that. What I need to know, and what is more important, how to apply these equations. Look at this example here. I have two cars. The first one at 3 positions have the same velocity. The velocity is constant. It is 10 minutes by second, 10 cent, 10, 10. And the acceleration in this case is constant and equal to 0 meter per squared second. Okay, but the other car changes its velocity. Look here, this velocity is 10, this velocity is 20, and this is 30. So I have acceleration not equal to 0 in this case. Do you think the position of the constant velocity car is the same as the accelerated car? No, the accelerated car will pass more distance or displacement when it moves, because it has acceleration, its velocity increase. So the position is different than the first one. Okay, I will solve now this example. I need to find the position for the cars at each given time. I have 3 times: at t equals 0, at t equal 5 seconds, and at t equal 10 seconds. Okay, for the first car, now I will start to calculate the position for the first car. I have the velocity and I have the times. I know the law of velocity. Velocity or average velocity is equal to the change in position divided on the change in time. So I need to find the position, which is delta x, which is the change from the initial velocity position to the final position in from A to B and from A to C. I need to find it twice. Now for B, delta x from A to B is equal to the velocity, the average velocity, multiplied by the time period from A to B. Okay, the velocity is 10 meters per second, multiplied by the time is 5 seconds at B. So the position now at B is equal to 50 meters. At point C, the same law. Delta x from A to C is equal to the velocity, which is the same 10 meters per second, multiplied by the time, which is 10 seconds at C. And the final displacement or change in position is 100 meters. So the body is moving, or the car moves from A to B 50 meters, yes, and 100 meters from A to C. Now how can I find the change in position for the second car, which has an acceleration? How much its acceleration? I need to compute its acceleration also. Okay, let us see now. How can we do that? For the next car, I have the time, I have the velocity at each position. So I need to find the acceleration. The acceleration is equal to change in velocity over the change in time, which is equal to velocity final, the final velocity minus the initial velocity divided by the change in time or the time period. If I take that 2 points A and B, so the acceleration is equal to velocity at B, which is the final point, minus the velocity at A, which is the initial point, and the change in the time between A and B is 5 seconds, delta T from A to B. The velocity at B is equal to 20 meters per second. 20 meters per second minus the initial velocity is 10 meters per second and the change in time is 5 seconds. Okay, 20 minus 10 is 10 over 5, which is equal, the acceleration now is equal to positive 2 meters per squared second. This is between A and B. What if I need to compute the acceleration between B and C? I'll find it. VC minus VB over delta T between B and C. The velocity at C is equal to 30 meters per second. 30 minus the velocity at B is 20. The time change between B and C is 5 seconds because the time at B is 5 and the time at C is 10. So the time change or the time period is 5. Now again 30 minus 20 is 10 over 5, which is equal to 2 meters per squared second, which is the same. Now what if I need to compute the acceleration or the average acceleration between A and C? It will be equal to VC minus VA, just like that. I choose the initial and the final points over the change in time or the time period between A and C. This is equal to the velocity at C is 30, the velocity at A is 10, the time period between A and C is 10 seconds minus 0, which is 10 seconds. Okay, that change in velocity is 20 and the time is 10, and this is equal to 2 meters per second squared. Okay, now we compute the acceleration three times during this track, and the acceleration is the same and in the same direction. We see that the direction to the positive x direction. In this case, we can call this acceleration a uniform acceleration or constant acceleration. Okay. The car changes its velocity 2 meters per second in increment in positive direction x direction. Okay, now I compute the acceleration and it is constant, which is equal to 2. Now I need to find the positions. Make it easy. I have 3 equations or 5 equations. I need to find the position at each time. Which equation of them I will use? The first one, I have the acceleration, I have the velocity, and I don't have the position in the first one. I will not use it. The second one, I can't find the position, and the second one I will not use it. The third one, I have the velocities and I have the time, but I don't have the acceleration, so I can't use it. The acceleration in the third one is 0. I don't have acceleration here. What if I have the acceleration? I would use the fourth one, this one. I can find the position, I have the time, I have the acceleration, I have the velocities. I can use this equation. So I will use it. X is equal to x naught. I will write it in different way now. Plus v naught multiplied by t plus half a t squared. If you don't carry these equations, just use a sheet of paper and look at it to write these equations. Okay, if I move the x naught to the left hand side, it will be x minus x naught, or x final minus x initial. X naught is the x initial. X final minus x initial is delta x. Delta x is the change in position. It is the value what we computed for the first car. Okay, delta x, I move this to this side, is equal to v0, which is v initial multiplied by time period. I can put it delta t plus half a t squared, or the change in time delta t squared. Okay, I will compute now the delta x from a to b. So I have is equal to v initial. V initial means v at a multiplied by the time period from a to b plus half the acceleration. The acceleration is constant. All the way the acceleration is constant. It is 2 multiplied by delta t from a to b squared. Okay, v at a, if you remember, v at a for the second car is 10 meters per second. Delta t from a to b is 5 seconds, from 0 to 5, plus half acceleration is 2. The time from a to b is 5, squared is 25. Simply I can cancel 2 with 2, so 50 plus 25, which is equal to 75. This is the change in position from A to B. The unit will be in meters. If you remember, for the first car, from A to B, the change in position was 50 meters, not 75 as the second car. The second car moves 75 because it has extra velocity, extra acceleration. Okay, I need to compute the change in position from A to C. This will be equal to V initial, which is VA, the change in time, or the time period from A to C now, plus half multiplied by the constant acceleration multiplied by the change in or the time period from A to C. Okay, the velocity at A is 10 again, multiplied by the time period from A to C, it is 10 seconds, plus half the acceleration is 2, the time period is 10, squared is 100. I can remove this 2 with this 2. This is 100 plus 100, which is equal to 200 meters. This is the change in position between A and C. So now I can compute the way from A to B. It is 200, from A to C. For the second car, it is 200 meters. Okay. In the same way, I can compute the change in position for the car from B to C. I can choose V at B is equal to 20. Delta t from B to C is equal 10 minus 5, which is equal to 5 seconds. And I can use the same equation. I have the V at B, the acceleration is constant, is equal to 2, and that's it. The units of the velocity always meters per second, the time in seconds, and the acceleration meters per square second. Okay, I'll move to the next sheet. It is long now, but please focus to what we need to do. Okay, this sheet, we need to read the question. We have scatter moving at a regular speed, V initial is equal to 1.75, began to climb up a hill. His movement slowed down because he moving upward with acceleration minus 2. Minus means that he is decelerating. Okay, and the scatter settled at the end of the level. Settled, what is the mean of this word? How much its velocity or his velocity at the end point, or V final? He reaches the stationary, so his velocity will be 0, V final. So I will use one of these equations to find how much the time to pass from initial to final positions. Okay, I will not compute the distance passed. I can use this equation, which is the first one. V final is equal to V initial plus A multiplied by T. I need to compute T. I have the acceleration, which is minus 2. This is minus. This is 2. V initial, it is the same like this one, 1.75. V final, it is 0. 1.75. Okay, how can I find T now? Now I have this equation, 0 equal to 1.75 minus 2T. I can move this minus 2 to the other side. It will be plus 2T is equal to 1.75. I can divide over 2 over 2. From that I can find T is equal to 1.75 over 2, which is equal to half. I will compute it. Which is equal to also 108, 0.875 time in seconds. Okay, now I can use any one of these equations to find the change in position over the hill. I will not use this one. I will not use this one because there's no any acceleration in this equation. I will use this one. I find the time. I know the time. I know V initial, which is this one. V final is 0 and I don't need it. X initial, I can suppose that this is X initial is 0, and I can use this for the equation. This example is solved now. What if I need to solve another example? A student, the first step, I need to read carefully the question. Then I need to know what is the law that I need to use. The third step, I need to know how to substitute each number from the understood question in the place of the samples and the quantities. Then I need to simplify my equations and find the last answer with the units, with the direction if it is needed. I have a time, it is directionless, it is scalar quantity. Now, this example, a student moves on a bicycle at a steady acceleration. Its acceleration is, the acceleration is equal to plus 1 meters per square second. To reach speed v final is equal to 7.5 meters per second. Okay, if the bike displacement is during this time is x equal to d, which is displacement, so x or delta x, which is equal to x final minus x initial, is equal to 19 meters. I need to find the initial velocity. Look, the first equation does not have the change in position. The second one is also I can't find the change in position. The third one is have the position and the velocity and the time. The third one have the time and the velocity and the position. I don't have the time in my equation, so I need another equation, which is the last one, which have v squared is equal to v0 or v initial squared plus 2a delta x. Okay, I will use the last one. I will write it here. V final squared is equal to v initial squared plus 2 multiplied by the acceleration, which is constant and uniform in our case, multiplied by delta x. Delta x is given, the acceleration is given, v final is given. I need to compute v initial. But be careful, I have in this case v final squared. So I will put 7.5 squared is equal to v initial squared plus 2 multiplied by the acceleration, which is 1, multiplied by the change in the position, which is 19. Okay, this value 7.5 squared is equal to 56.25 is equal to v initial squared plus 2 multiplied by 19 is 38. Okay, I need v initial. I can add and subtract 38 from both sides, or I can move this value to here. It will be 56.25 minus 38 is equal to v initial squared. Okay, v initial, no, v initial squared is equal to 18.25 meters per second squared, because the velocity is squared here. Now I need v initial, so I have to take the square root of 18.25, which is equal to two values, plus 4.27 and minus 4.27. Okay, of course meters per second. I have to accept one of them because my movement in the positive direction, not the negative direction. I have the positive initial velocity, because if I have the negative initial velocity in this direction, then v initial here, v final here will be in the negative direction, not in the positive direction. So I will neglect this one and I will accept v initial is equal to 4.27 meters per second, and the final velocity is 7.5. That means that body is accelerating. Okay, this is the second using these equations. We have also this example. You can do the same as what I did now. I will use this equation, the fourth one. No, it is not clear enough on the video. I'll fix that. But the acceleration in this equation in y direction, the acceleration for free falling bodies, for this is a free falling body, the acceleration of it is 9. The acceleration downward to the center of earth, if this is earth, the acceleration is equal to g due to gravity, which is equal to 9.8 meter per square second downward. That is depend, I can take it positive or negative, but in general we take the upward in positive direction and the downward in negative direction. So I will take g is equal to minus 9.8. This is simple. For this example, I need to find the depth of the well. So the depth will be downward. It is delta x or delta y or h or d, but it will be downward. In this case, it will be negative value, and I need to use the g, the acceleration due gravity, which is g, and put it 9.8, and the initial velocity for free falling bodies. This is the pen. Free falling body, you see that on the videos. The initial velocity is 0. V initial, I will put it 0. I can find the V final, and I can find the depth, and I can find anything I need. Okay, the last sheet, it is the question in page number 42. We need to understand the question and you can find the solution easily. We have a crocodile at the position of 0, and its equation of motion x of it is equal to 0.25 multiplied by t squared. We have two ducks. They are away from him 3 meters. This is 1 meter. This is 2 meters. This is 3 meters. Look. The first one, it has a position at 3 meters, but its position reduced by this rate. So the first one, the position reduced, it is coming toward the alligator. Okay, so the first one has the equation of motion for d1, for duck 1, is equal to 3 minus, I will not put the units now, minus 1.5 multiplied by the time. The second one is going away from him, so x for the second duck is equal to 3 plus 1 meter per second multiplied by the time. Okay, now the change in position for the alligator is in positive direction. The time is positive always, and the constant here is positive, so the crocodile and the alligator is going to the positive x direction. We can find that the first duck will meet it at first, then he will find the second duck after a period of time. We can calculate this. If you need, visit the office hour and I will solve this question with you. Also, you need to remember that where's the first sheet? The first sheet. This is it. Yes. When we use the functions in mathematics, in physics, we need to use these functions to find the position for each animal. Try it. If you can't do that, just meet me in the office hour, and thank you. Meet you in the next examples.
Hi students, now I will talk about the free falling objects. We solved in a previous example a free falling problem, but now we will take it in more detail or more examples. For a free falling object, any falling object to downward freely like this, in this way, okay, if I throw it like this or just I leave it to just go downward, all the falling objects are going to the center of the earth, okay. It's the direction of this falling is to direction of the center of earth, okay. The acceleration of these objects is always downward to the center of this planet, okay. Or if we are on another planet, for example, on a moon or on Jupiter, not on Jupiter, on Mars or something like that, it will be downward to the center of that planet. We need to be note that there is a velocity is equal to 0 at a certain point. There is a velocity equal to 0 at a certain point. For example, in this experiment, this point the velocity is 0, the starting point. But if I throw the pin upward, it reaches a maximum height, then go back down. At the highest point is the velocity at the highest point is 0 in this case. We will see that in example. The acceleration is equal, we will name it g due to gravity. It is equal always 10. I'm sorry, it is not 10, but approximately equal to 10, but it is equal to 9.8. Be careful. You can solve it. Solve the examples. An example using it as 10. I solve the examples using g equal to 10. You can use it 10 and or 9.8 meter per square second. But it is always downward. Always downward. Okay. We have to choose a suitable direction. Suitable direction. That means we need to choose the downward, even negative or positive. That depends on the problem. It is our example or our problem. We can choose the direction as we need. The mass of that object will not affect the motion. Even it is light or heavy, it will not affect the motion. Okay, you will see the experiment of free falling body for the hammer and the feather on moon surface. Also in a vacuum room, the free fall is the same for both bodies. We have the main three equation of motion. In x direction, v2 is equal to v1 plus at, v2 v2 square is equal to v1 square plus 2ax. X here is the change in position in x direction. The velocity v2, v1, v final, v initial, it's the same. Also, the final position is equal to the initial position plus v initial multiplied by t, or delta t, the time period, plus half a t squared. But we will take these equations in y direction. We will exchange a by g and x by y, or delta y, delta x by delta y. The time is the same, and the x in horizontal direction will be y in vertical direction. Okay, let us look at the first example. If we have a building, we have a free falling object from the top of that building, and the height of that building is 100 meters. It's okay to choose any height for this building. Okay, we have many points. I chose them arbitrary. Point 1, 2, 3, 4. The height at the first point is the same height of the building, which is 100. The height at the second point is 80 meters. The height at the third point is 20. The final height, which is h4, is 0. It is the ground. We need to find the velocity at each point. Also, we can find the time at each point using the equation of motion, any one of them. Now, for this problem, for this object, v is equal to 0 at point 1, because it starts its motion from that point. So v equal to 0, or v1 is equal to 0. Also, we need to choose the upward direction as positive and the downward is negative. And we have the equations. Okay, if we need to find, for example, the velocity at the second point, using the second equation to find v2 and v3 and v4, it's okay. v2, I use the second equation. Why? Let us look at the first equation. v2 is equal to v1. v1 is 0 for all of them. So this term is 0, 0, 0. 0 multiplied by t. Okay. y0, it is 100. It's given. Y initial. But in the first equation, we know the g, the acceleration, which is negative 10. We can use it negative 10, okay? Or negative 9.8. It's okay. The time is unknown in the first equation, so we can't use the first equation. The second equation, also the third equation, we need to have the time, but we don't know it. But in the second equation, we have g, we have the change in position, y2, y1, we know them. Okay, now take a look. v2, the velocity at point number 2, squared is equal to v1 squared plus 2 multiplied by g, which is, I take it minus 10. I can take it also minus 9.8 multiplied by delta y. Delta y, which is y2 minus y1. y2 is 80 at this altitude. y1 is 100. So we have, this is 0, this term is 0. We have 2 multiplied by negative 10 or negative 9.8, you can use it, multiplied by negative 20. This will be equal to negative with negative, it will be zero, positive, and the final will be 400 meter per second all square, because the velocity is squared. The units of velocity is meter per second, but we have velocity squared, so this unit is squared. We need the velocity, not the square of it. It is the positive and negative. In mathematics, maybe two values, positive or negative value. The root of 400, we have two values, positive 20 meters per second or negative 20 meters per second. Which value of them, the mathematicians will take both of these values, but we are physicists. We know and we understand this problem. The sign means the direction. What is our direction in this motion? It is downward. The downward is negative direction. So we need to take the negative 20 meters per second. This is the right value. This is the wrong value because of the direction. Okay? This is 20. But if we take it, if we take G is equal to negative 9.8, the velocity will be, I'll calculate it, to 9.8 multiplied by 20 was if G equal to negative 9.8 منها V2 is equal to negative 19.79, almost 9, which is equal almost to negative 20 if we approximate it, meters per second. See why we always approximate G to negative 10 or to 10, not 9.8. It's okay, not that difference. Now, what is the time to reach point number 2? Time to reach from point number 1 to point number 2. In this case, we need to use another equation contains the time. We can use the second equation, the third equation, and the first one. The third equation, we have a squared term here. It will load another step in solution. If we are in exam, we don't need to spend more time, so we will use the most simple equation. So I will use the first one. I can use this one. I have y initial and I have y final. I have G. Just I need to find T. I need to use another step, which is square root. Here, directly, V2 is equal to V1 plus GT. V1 is 0. V2 is negative 20 is equal to 0 plus G negative 10 multiplied by T. Again, we can use it, negative 9.8. Now we have to order our formula. It will be negative 20 is equal to negative 10 multiplied by T. We need to divide the both side over negative 10. Look, what if we use V2, the positive value, which is positive 20? it will be, in this case, this is positive 20, this is positive 20, the time will be in negative value. There is no time in negative value if we use the velocity v2 positive. Be careful, the sign has a meaning in physics. This is the time to reach the point number 2 from point number 1. It is 2 seconds. You can use these equations to find the velocity at each point, to find if the time from here to here is 2 seconds. You can find the time from 1 to 3, from 1 to 4, and then you can find the time periods between any of these points. Okay, so complete it, and we can complete another part in the class. Look at this second example as one in the book. If we have a thrown object from the top of that building with initial velocity positive 10 meters per second upward. Positive means upward. Then this object will reach a highest point, then it will fall again to reach the ground surface, and we have a hole or a well near this building. This depth is negative 20 meters. Okay, now we need to name the points. The starting point is 1, the highest point is 2, again the same highest, I name it another when the body return back to the same height, I name it 3, 4 at the middle of the building, 5 at the bottom of the well. Okay, there is a different points between one, there is a different situation between 1 and 3. Okay, we will see that now. Look what I need. Find the highest y, which is y at 2, with respect to the ground, this height. Find the velocity at each point. You can do it using the equations. Find the time at each point. You can do it. Okay, also if I order to find the time period from 4 to 5, or from 3 to 4, or from 2 to 4, you can find it. Okay, in this problem, v1 at this point is not 0. It is not 0, v1. The previous example, v1 was 0, but we have here v1 is not equal to 0. If you remember, one of the properties of the falling object, we have a velocity equal to 0 at a certain point. Where is that point? It is at the top, the highest point here, at point number 2. The velocity at the highest point is 0, which is at point number 2. Okay, and the acceleration always equal to g, downward, always, even at this point, even at the, look, at the highest point, the velocity is 0, but the gravitation is exist, and the acceleration is also exist downward in negative direction. By the way, I used it negative 10, not negative 9.8. It's okay. Okay, now the highest point, I need to find it, which is y2. I have the equations. Now I didn't name them v2, v1, or y naught. I named that as v final, v initial, y final, y initial, and we have also here delta y, which is y final minus y initial. Also the time here is the time period delta t, which is equal to t final minus t initial. That depend on that part of that problem. Okay, we can use the second equation again. Why? Because we don't know the time, so we can't use the first and the third equation. We know the velocity, we know g, we need to know the altitude, y. Okay, the second equation, v final is equal to v initial plus 2g delta y. Okay, now to see, v final is v2 at the point, the highest point. V1 is the initial velocity, which is positive 10. This is V1. 2g, y2 minus y1, which is the altitude between the 2 points 1 and 2. طيب. Now V2, the highest point, it is 0. The velocity at that point is 0. V2 is equal to 0. V1 is positive 10, it is given. 2g, g I used it, negative 10. It is negative downward and I approximate it to 10. Multiplied by y2 minus y1. y1 is the building height, which is 100. And y2, it is the height of the second point from the ground. What we need to do now, we have now just one unknown variable. We need just to order our formula. 0, 10 squared is 100, minus 10 multiplied by 2, it is 20, multiplied by y2, minus 20 y2, minus with minus positive. Here we have 20, here we have 100, it will be 2000. Okay, now the negative term, I will move it to the opposite side, which is negative 2y. It will be positive 20y. I'm sorry, 20. Okay, what else? It is equal to 2000 plus 100. Now divide over 20. 2100 divided over 20, it will be equal to 105 meters. 105. Remember that the building is 100 and the altitude of the point number 2 is 105. So the difference in the altitude between the point number 2 and the point number 1, it is 105 minus 100, which is 5 meters. Okay, almost 2 floors. Okay, now let us complete. This is the part of our building. We can find T at point number 2. Look, they're required to find the velocities and the time at each point, at all the points. I will solve that for point number 2 and for point number 3. It is easy to complete that, I think. Okay, at point number 2 we need to find the time. Now these are the equations. I don't know them yet, so I will write them on a paper and then I use them always. I cheat from them always. Okay. Also in the exam you will have a formula sheet. We can use the first equation. Also we can use the third equation, but we have a square term here. This will load another steps to solve. Sometimes we need to use the third equation, but now we will use the first equation. V2 is equal to V1 plus GT. The time here is the time from 1 to 2. Okay, V2, the velocity here is 0, as we know. The velocity at the first point is positive 10. G, I take it negative 10 because negative and 10 approximated, multiplied by the time period from 1 to 2. So we have 0 is equal to 10 minus 10t. I will move the negative 10 to the opposite side. It will be positive 10t is equal to 10. T is equal to 10 over 10, which is equal to 1 second. So this body spent 1 second to move from the top of the building to the top of the motion. Okay, from point 1 to point 2. Okay, now we need to find the velocity at point number 3, which is the same height as the point number 1, which is 100. Now again, we can use the equation number 2. It is not complex. We don't need to complicate the problem. We need to use any equation suitable to our the required part. Okay. Equation number 2: V final minus V initial plus 2G delta Y. V final now is V3. V initial is V2. V2 is equal to 0, if you remember that. So V3 is required to be solved. V2 is 0 plus 2G is negative 10. Delta Y. Okay, delta Y is for Y final, which is Y at 3, minus Y initial. Y final here is 100. Can you see that? 100. Here 105. So 100 minus 105. So V3 squared is equal to 0 plus 2 multiplied by negative 10 multiplied by negative 5. This will be equal to 100 meter per second squared. This is V3 squared. V3 is the root, positive, negative, the root. Again, the root of 100 is 10, positive or negative. What is the accepted value? The motion now is downward, so it will be negative 10. Look, the magnitude of the velocity at point number 1, which is the initial velocity, is 10. The magnitude of the velocity, which is the speed, at point number 3 is the same because they are at the same height, and the resistance of the air is neglected, or we don't care about it. The velocity or the speed without any direction is 10. The speed without any direction is 10 at the same height here. Okay? If we talk about the velocity, we need to put the direction. The direction is negative here and positive here. You can also find the velocity at this point, and you find that the speed here is equal to the speed here. The same. We will see that when we discuss the projectile motion. Okay, what is the time now? Again, we can use equation number 1 to find the time period from point number 2 to point number 3. This, to climb up, we spend 1 second. You will see that to go down again, we will spend also 1 second. So the flight time from point 1 to point number 3 is 1 second plus 1 second, which is 2 seconds. Now, how long the time from point number 2 to point number 3? We can use also again equation number 1. V final is equal to V initial plus GT. V final is V3, V initial is V2 plus GT, delta T. We need the delta T period, which is the time from T3 to T1. The velocity at point number 3 is negative 10. V3. This is it. Velocity at the highest point, V2, is 0. G is negative 10 or negative 9.8, it's okay. Multiplied by the time period. What we needed, the time period, all of it, but I write it here to know that the time period is from between 2 and 3. So negative 10 is equal to negative 10 multiplied by the time. Just divide negative 10 over 10, it will be 1 second. So the climbing time is the same as going down time. Again, you can find, now you know all the information, all the properties of the system at this point, then you can find the system unknown velocity and time at point number 4 and at point number 5. You have the heights. Okay, do that by yourself and good luck. Hi students, how you doing? We'll talk now about section 2.6, which is velocity and position by integration. From mathematics, we need to note that for f of x, we are talking math, not physics now in this part. For f of x, if we need to find f prime, we need to derive it with respect to x. And if we integrate, we need to know what is integration. If we need to integrate the f prime of x, it will give us f of x. And the limited integration from x1 to x2 will give us f of x2 minus f of x1. But most of times we have f of x1 is equal to 0. So we can find that f of x is equal to the integration of f of prime. This is f of prime. So the integration is the inverse operation of differentiation and vice versa. For example, we are just in math now. If we have f of x is equal to 3x cubed minus 2x, what is the differentiation of that function? D by dx to f of x is equal to d by dx to 3x cubed minus 2x, which is equal to 9x squared minus 2, which is f prime of x. Now, what if we need to integrate f prime of x with respect to x? It will be the integration. It is unlimited. It's open integration. There are no limits like in this way, like this integration. This is the f prime of x, 9x squared minus 2. When we need to integrate it, we need to raise the power of x and then divide over that numerical value, which is the new power of x, and we have the same coefficient, which is 9 minus 2 minus 2. We have x to 0. It is x to 0 here. If we add 1 to 0, it will be x to 1 over 1, which is x, plus c, which is the constant for the integration. In this case, we have 9 over 3, which is 3, x cubed negative or minus 2x plus c. If we have limited integration, then c we need it to be as 0. But this answer in general. Look at it, the same integration for limited values, which is the limited values are x initial and x final. We have in physics t initial, t final, x initial, x final, v initial, v final, and so on. It is easy operation in mathematics to know the differentiation and the integration. Now, again, in physics, now we will talk in physics. We have x is a function of t. If you remember that, we have 3 equations of motion. If we derive x with respect to t, it will be x dot the rate of of change in the position with respect to t. X dot, not x prime. It is x dot. If we derive with respect to x to the position, it will be f prime. But if we derive with respect to time, it will be dot. Okay? X dot, which is the first derivative of x, which is, it will be equal to v of t. It is the velocity as we, or the speed as we talked before. What if we need to find the position with respect to t? If we derive, if we integrate x dot with respect to t, which is the same as integration of velocity function of t with respect to t, it will give us a gain to the x of t function. So we can move between x and v as a function of t by differentiation or integration. And we have two limits. We have t initial and t final. T initial it may be equal to t0. Sometimes it is equal to 0 seconds, and this is t1 or t2 or anything like that. So we have x final is equal to, if we integrate v of t, it will be equal to x final minus x initial as the properties of the integration. We need just to have, or to suppose that, or name x at t final, this one we can name it x or x of t, and x at t initial, x naught, it may equal to 0. Now we need also to order this. We need to bring this term to here. It will be plus against the negative. So x final will be equal to x0 plus the integration from t1 to t2, or from t initial to t final, for the velocity or the speed with respect to time. T initial may be equal to 0. This is the relation between x and v, and x dot and v. What about the relation between v and the acceleration? It is the same. If we derive the velocity with respect to time, it will give us the acceleration. Also, we need to know also the relation between the acceleration and the position. We know that x dot is equal to v. V dot is equal to a, the acceleration. But v is x dot. We have another dot here. X double dot is equal to the acceleration, and x dot is equal to the velocity. The integration in mathematics is the area under the curve. So if we have v versus t graph, and we need to know what is x. X is x between t initial and t final. It is the area under that graph. And the acceleration is, as we see before, the acceleration is the slope at that point, at a point, okay? If we look at the acceleration graph with versus t, if we integrate from point t1 to t2 or t initial to t final, the area under that curve is the velocity. Okay? Be careful of that. This is the final idea. We have a relation between x, v, and a, the acceleration. All of them are functions of t. For example, if you have this function in x, if we derive it with respect to t, it will give us the function of velocity or the speed with respect to time. If we derive it again, it will give us the function of acceleration with respect to time. If we integrate that acceleration by integration, it will give us the speed. If we integrate the function of speed as here, it will give us the position function with respect to t. And note that the derivative is related to the delta x over delta t, for example, or the rate of change with respect to time, which relates to a slope of that function at a point or between 2 points or something like that. And the integration for a function is the area under the curve. So these two ideas are important. You will see these curves and this definition in the lab section. Now, let us look at this simple example. Okay, look here. If we have the acceleration as a function of time, 5, 15, t squared plus 3. The unit is meter per square second. It is acceleration. Okay. So 3 is acceleration. 15 t squared, all of it is acceleration. These terms, each term is acceleration. So the dimensionality should be verified. The time is always big or equal to 0 in seconds, okay? And we have initial values at t equal to 0. At initial time t equal to 0, we have the initial position is 5 meters and the initial velocity is 0 meter per square, okay? We need to find the speed and the position or distance. Relations as a function of time. Okay, for the speed we need now to jump. We have the acceleration is given. We need to jump from acceleration to velocity, then from velocity to the position or the distance function. Okay, the first step, we are here, we need to move here. If we are at velocity, if we have the velocity function, then we can go by differentiation to the acceleration and by integration to the position function. Okay, velocity as a function of t is equal to v at t equals 0 or v naught plus the integration from 0 to t. The initial value of the integration is 0, the final value is t. We have a function. The integration for the acceleration as a function of t. Now the initial value of the velocity is 0, v naught is equal to 0. It is simple. Plus the integration of 15 t squared plus 3. The integration will be 15 multiplied by t cubed. We raise the power and divide over that numerical value, new 1, which is 3, plus 3t, because t here is t to 0. Then it will be t to 1 over 1. From 0 to t, we need to put t, then minus the magnitude of 0, velocity. So we put 5t cubed, because 15 over 3 is 5, plus 3t, minus, now we put 0, 5, 0 to 3, plus 3 multiplied by 0. This will be 0. So we have the velocity or speed. We don't know the direction, so we'll call it speed relation of time is equal to 5t cubed plus 3t. Now we can find the position. We need to integrate again. X of t is equal to x. It's the same relation, but we need to change x, v by x, and acceleration by v as a function of time. Integrate from 0 to t. But the initial position, it is at x at t equal to 0, x equal 5 meters. Then x naught is 5. The integration for the velocity function. Velocity function is 5t cubed plus 3t dt. And the integration from 0 to t. This is the result resultant value for the integration, t cubed, it will be t to 4 over 4 plus 3t squared over 2. And we have the initial position 5 as is. So the final function x of t is equal to 5 plus 5 over 4t to the 4 plus 3 over 2t squared, and the 0 application here is 0. So this is the position function for our problem. Now if I give you any time, you can find x and v and so and a also. Look at this example or problem from paper page 62, which is 2.49. We have a rocket. We need to understand these questions. Start from rest. Rest means the initial velocity is 0 and moves upward in y direction. We can name it y, we can name it x, but we will take it as y. From the surface of the earth, surface of the earth means at y equal to 0. We can take it as y equal to 0 for the first 10 seconds. So we have a period of time. We have acceleration function ay is given by ay is equal to 2.8 meters per second 3 multiplied by time. All of this term is acceleration. Okay, now where the positive direction for y is positive y direction, okay, is upward. What is the height? We need to find the y position of the rocket above the surface, above the 0 position of the earth at t equal to 10 seconds. We have the time at that time. We need to know the position function. What is the speed also at y equal at the when it is 325 meters above the surface of the earth. So we know the altitude of that rocket, but we don't know the time. We need the speed at that moment. Okay, now we have the acceleration function, which is 2.8 as given, meter per cubed second multiplied by t. We have here another function. We have here more simple function. And we have initial conditions, which is v naught is equal to 0 at t equal to 0, and y naught is equal also to 0. We have the position direction upward. We need to find the position at t equal to 10 seconds and the speed at y equal 325 meters upward. How much? Okay, by integration, we need to use integration. V of t is equal to v naught plus the integration of the acceleration with respect to t. V naught, we know it's 0 as given. Okay, the integration from 0 to t to 2.8 t dt. This will give us 2.8 t squared over 2 from 0 to t. The 0 term will be cancelled, will be go, okay, will not affect, and we have 2.8 over 2, it will 1.4 t squared. Then the speed function of t is equal to 1.4 t squared meter per second. Okay, what about the position? We need to integrate again because we are at this point. We know the acceleration. We need to integrate to go to the speed, then to integrate again to go to the position function. We need to go up by steps, by upper step by integration. Okay, now the velocity function, we need to integrate it, which is 1.4 t squared dt. The initial position y naught is equal to 0 plus the integration, the limits for that, just this term, not for this one, 1.4 t cubed over 3, the integration of t squared. This will give us 0, it will be 0, it will not appear here, plus 1.4 over 3 t cubed meters. This is the position function. Now let us find the required parts. Now we have y as a function of t is equal to 1.4 over 3 t cubed in meters. The speed function in y direction is equal to 1.4 t squared meters per second, and the acceleration function also in y direction is 2.8 t meter per square second. We can't find anything. We can find the velocity, the position, the acceleration at any time, at any point. Okay, so what is the altitude at t equal to 10? We just need to put 10 in the position function. It will be 1000 multiplied by 1.4, which is 1400 over 3. It will be 466.67 approximately meters in upward direction. What about the velocity at y equal 325 meter? What is t? We have v as a function of t, but not as a function of y. From y function we can find t. We know y is equal to 325, which is equal to the function, which is 1.4 over 3 t cubed. Now multiply by 3, divide over 1.4, will be equal to t cubed. It will be alone now. What is t? It is the square, not square root, it is the cubed root of this quantity, or this quantity, or to the third. Okay, 1 over 3. This is the same as cubed square root. I'm sorry. So t in this case is equal to 8.86 seconds. Now we can find the speed. We need to use this t in v or v function. We need to put 8.86 in v function. It will be equal 1.4 multiplied by this value squared as given. It will be equal 109.99, which is approximately 110 meters per second upward, because it is a positive value. Now this is another problem in the same page, which is 2.50. It is simple, just like that first example. You can do it, and I think this part or this section is very important to us in physics and in mathematics. Thank you.